today's video, we will configure HTTP load balancer with autoscaling. So I will be following the steps which is mentioned here. First, I will be creating a health check firewall rule. This health checks determine which instances of a load balancer can receive new connections. Next, we will create a NAT configuration using cloud router. So whatever backend instances that we create as part of this lab, we will not be configuring any external IP address. Instead, we'll be setting up a cloud NAT service to allow these VM instances to send outbound traffic only through the cloud NAT and receive inbound traffic through the load balancer. Next, we will create a custom web server image for the backend of the load balancer. In fourth step, we will be creating an instance template based on the custom image. Later, we will create instance group. Here, we will be creating a managed instance group using an instance template to create a group of identical instances. So we will use this to create the backends of the HTTP load balancer. Finally, we will configure the HTTP load balancer to balance traffic between the two backends. Then we will conclude with the lab. So let's start with the lab. So let's first create a firewall rule to allow health checks. In the cloud console, here under navigation menu, click on VPC network and here click on firewall. Here you can see there are 4 rules already available. ICMP, internal RDP and SSH firewall rules already exist. Click on create firewall rule. Provide a name here. Logs I will be keeping it as off. Next under network, select the default network. Next under targets, select specify target tags. Under target tags, you need to add allow health checks. So add this tag. Then under source filter, add IPv4 ranges. And here under source IPv4 ranges, provide the IP ranges. Provide these two IPv4 ranges. Next under protocols and ports, select specified protocols and ports. Select TCP and provide the port number as 80. So once this is done, you can click on create. So firewall rule is now created. Next, we need to create a NAT configuration using cloud router. Here we will be setting up a cloud NAT service to allow the VM instances to send outbound traffic to the cloud NAT and receive inbound traffic through the load balancer. To create a cloud router instance, you need to navigate to the click on network services. Under network services page, click on cloud NAT. Here click on get started. This cloud NAT will let your VM instance and container pods to communicate with the internet using a shared public IP address. So let's provide a name here, gateway name. So under gateway name, I will be providing nat-config and network. I will be selecting the default and the region I will be selecting US Central. Under cloud router, click on create new router. Here provide a name. You can provide a description here. As you can see, the network will be default and the region is US Central. So here click on create. Here click on create. Here we have created a NAT configuration using cloud router. So as you can see here, the status is running. So let's create a custom web server image for the backend of the load balancer. Let's go back to navigation menu. Here under compute engine, click on VM instances. Click on create instance. Under name, I'll be giving it as web server and the region and zone it will be US Central. Under machine configuration, I'll be keeping it as E2 series and machine type E2 medium. Next under boot disk, I'll be changing the image to Debian GNU Linux 10 Buster. Here click on show advanced configuration. So here under deletion rule, select keep boot disk. Next click on select. Identity and API access, I will keep the access scope as allow default access. So next let's move on to advanced option. Under advanced option, click on networking, give the tag allow health checks. Next scroll down under network interfaces, click on this default. Scroll down, here you can see external IPv4 address. Click on this and select none. Next click on done. Once it is done, you can click on create. So this will create a VM instance. So let's customize this VM instance. Click on SSH to launch a terminal and connect to this VM instance. We have connected to our VM instance. So let's install Apache 2 on this VM instance. Execute sudo apt get update Next, sudo apt install Apache 2. So this will install Apache server. The Apache is installed. So let's start the Apache server by running the command sudo service Apache 2 start. You can check the status by running status command. So here you can see it's running. Installation was successful, but when a new VM is created using this image, the freshly booted VM does not have the Apache web server running. In order to set the Apache service to automatically start on boot, we need to run the following command. This command will set the service to start on boot. Let's go back to our Cloud Console. Here, under More Actions, click on Reset. In order to verify if the update-rc was successful, let's reset our web server. So this reset will stop and reboot the machine. It will keep the same IPs and the same persistent boot disk, but memory will be wiped out. So let's click on reset. Again, let's connect to this. Our Apache web server should be available since we have executed update-rc command. So let's check the status of our Apache server status. It is running. So our command was successful. Now let's prepare our disk to create a custom image. You can close this one. Go to the Cloud Console. So click on this VM instance. Here under storage, under boot disk, you need to verify when deleting instance is set to keep disk. Let's go back. Here under more actions, let's delete this VM instance. Now the VM instance is deleted. Let's verify if our disk still exists or not. Here under disk, click on disk. You can see the disk still exists because there under configuration we have set the value to keep disk. That's why the disk is still available. Now let's create a custom image. So here click on images. Here click on create image. Provide a name to your image. So source you can keep it as disk, and source disk it will be web server, and the location I'll be keeping it as multi-regional. Click on create. So here we have created a custom image. Using this custom image we can start multiple identical web servers. So image is created. So we can delete this disk. This is not needed anymore. So you can click on this and delete this disk. So next we will be using this image to define an instance template which can be used in the managed instance group. So let's move on. And here we will be configuring an instance template and create instance group. Managed instance group uses an instance template to create a group of identical instances. We will use this to create the backends of the HTTP load balancer. So let's configure the instance template. Go back to navigation menu. Under navigation menu, click on compute engine and instance template. So using instance template, you can create a VM instances and managed instance group. So this instance template is a place where we define our machine type, boot disk image, subnet, labels and other instance properties. So we are under instance template page. You click on create instance template, and for name you can provide a name here to your instance template. Next under machine configuration, and select the series. So I'll be selecting N1 series, and in the machine type I'll be selecting F1 micro. F1 micro 1B CPU I have selected. Scroll down under boot disk, click on change, and here click on custom images. So here under image, click on drop down and you select my web server. So this is a custom image which we had created earlier. And boot disk type I will keep it as balanced persistent disk, and size I will keep it as 10 GB. Next click on select. Next scroll down. The identity and API access I will keep it as default, allow default access. Next scroll down under advanced options, click on networking. Here under network tags you have to provide this tag. Scroll down under network interface, click on this default. Scroll down under external IPv4 address, click on this drop down and select none. Click on done. Click on create. Now the instance template is created. Now we need to create a health check for managed instance group. And go to compute engine and here click on health checks. Provide a name to your health check and the scope will be global and the protocol will be TCP and port will be 80. Click on create. Managed instance group will use this L check to proactively signal to delete and recreate instances that becomes unhealthy. So now we are done with creating a health check. So let's create the managed instance group. Under compute engine, click on instance group. Click on create instance group. Here provide a name to your instance group. In instance template, click on drop down and select your instance template. Under location, I'll be selecting the multiple zones. It will be US Central 1. Under auto scaling, I've selected add and remove instance to the group, this option. So there are 3 options available. I'll be selecting the first option. Under minimum number of instances, I'll be giving it as 1, and the maximum number of instances, I'll be giving it as 2. Under auto scaling signals, click on the CPU utilization. Under signal type, we're selecting the second option, HTTP load balancing utilization. Under target HTTP load balancing utilization, here I'll be giving the percentage as 80. Now click on done. Next, under cooldown period, I will give 60 seconds. This managed instance group uses auto scaling capabilities that allows you to automatically add or remove instances from a managed instance group based on increases or decreases in the load. And a VM instance lifecycle, I will keep this first option, keep the same instance configuration. Under auto healing, click on this drop down health check and select the health check which we have created. Initial delay, I have set it as 60 seconds. So instance group will wait 60 seconds after initializing the boot up of a VM before it checks the health check. So for this lab purpose, I have kept it as only 60 seconds, 1 minute. So you can set the larger initial delay like 300 seconds based on your requirement. Here click on create. Instance group is created. So let's create one more instance group in another region. Here I will be creating a instance group in Europe region. Select your template, select multiple zones. Here select Europe West. Under auto scaling, set the same, that minimum number of instance to 1 and maximum to 2. Here under auto scaling signals, we'll select the signal type to HTTP load balancing utilization. So here we'll set the target HTTP load balancing utilization to 80%. Click on done. Next, under cooldown period, I'll set it as 60 seconds. Scroll down under health check, select the health check which you had created, and the initial delay, I will set it as 60 seconds. Once done, click on create. You can ignore this warning because I'm not yet assigned any backend service for HTTP load balancer, so we will do it later. So click on confirm. So you can ignore this warning because we have not yet attached backend service to the instance group, so we will do it later. Here we have created 2 instance group, one in US Central 1 and another in Europe. Let's verify if the VM instances are being created. So let's go back to compute engine and VM instance. Here we should have instances created. So there are 2 instances which got created. So these instances are part of our managed instance group. Let's move ahead and configure our HTTP load balancer. We will configure HTTP load balancer to balance traffic between the 2 backends. So let's go back to navigation menu. Click on network services and here click on load balancing. Here click on create load balancer. So there are 3 types of load balancing available. We will be making use of HTTP load balancing. So click on start configuration. Here under internet facing or internal only, select from internet to my VMs or serverless service. Under global or regional, do you want to deploy your application global, regional or classic mode? Second option we'll be selecting. Click on continue. Load balancer name you have to provide. So I'll be giving HTTP-LB. Now let's configure our front end. Here you can provide a name and a protocol, HTTP, and under network service tier, select premium, IP version IPv4, IP address ephemeral, port 80. Click on done. Next, click on add front end IP and port. So under protocol, you can select HTTP, and here we will be selecting IPv6, and IP address will be auto-allocate. Click on done. Click on backend configuration. Click on backend services and backend buckets. Here click on create a backend service. Under name, I will be providing HTTP hyphen backend, and backend type will be instance group. Protocol will be HTTP. Scroll down and a new backend and instance group. Select US Central 1 and the port numbers I'll be giving it as 80. Under balancing mode, we'll be selecting rate and maximum RPS. I'll be giving it as 50 and capacity it will be 100%. So this configuration means that the load balancer will attempt to keep each instance of US Central managed instance group at or below 50 requests per second. I will give the same, that is 80. The balancing mode here it will be utilization. Maximum backend utilization it will be 80 and the capacity it will be 100. So this configuration means that the load balancer will attempt to keep each instance of Europe West 1 managed instance group at or below 80% CPU utilization. Done. So we have added two backends here. Next, scroll down. Here under health check, we need to select our health check which we had created. So you select the health check, HTTP health check. Let's enable the logging. Sample rate, I will keep it as 1. Let's click on create. Review and finalize, and then finally click on create to create your HTTP load balancer. So let's click on create. So as you can see here, it's creating a backend service. It has created one backend service with 2 instance groups. So we have successfully created our load balancer. If you found my video helpful, please like and subscribe to my channel and stay up to date with the latest content on this channel. Thank you all for watching. See you in the next video.